Oh, hey there, fellow wackadoos. Hello again. Welcome back to Dr. Doodle's QBasic Asylum. As always, I am your guy, Chief Nutjob around here, Dr. Doodle. Now, repeat offenders, returning viewers might notice something just a little bit different about me tonight. I'll give you a few minutes to figure it out. Let's see, what could it be? That's right, it's the lid. Genuine stovepipe felt hat here from straight from Alaska. Beautiful young missus and we took a tour up to Alaska. Makes it our 50th state. That's right, we've been to them all. I wouldn't lie to you. I mean, about you, sure, but not to you. So yeah, we've been to all 50 states now and had to get the lid. I mean, come on. So between that and a recent trip to Red Hoods, well, we've been pretty tied up with that along with work. I think you'll hopefully understand why I haven't posted for a while, but I'm back now, much to your chagrin. So you're not rid of me yet, so I'm here, and welcome to, let's see, this is episode 33, QBA33, yeah, QBA33 DoodleBase, the QBasic database. Yep, so let's check this out. Hang on a second. Here we go. Alright gang, here we are at a QBA33.base, DoodleBase as I call it, by Dr. Doodle and copyleft 2025 as always. Now before we dive into the guts of this pig, let's run or see what we got here. Now take a quick look at run. There we go. Alright, here we are. We got our action menu. Notice we got open file, enter, delete. Now one thing about this interface, I didn't want to bother with a mouse and all that stuff. But now originally I had, like for example, O for open, E for enter, D for delete. Now you see a problem here? S for search, S for sort. If I press S, how is the computer going to know which function I want to do? Well, so I thought I'd number them all 1 2 3 4 5, but then you're hunting all across the top of the keyboard here looking for the numbers. So I thought, well, this might be the easier way to do it. I guess you might call it continuity, to keep everything kind of the same. You're just working with two keys, the up key and the down key, well, and enter. But I mean, instead of hunting for numbers or letters, whatever, we just move the cursor down or up using the up and down key, obviously. So to start out here, we open the file, so we hit enter, boom, and here's a list of files that we have here, all QBD, which stands for QBasic Database. Now, we want to start with tunes, TUNES QBD, kind of tough to type with this camera here in front of me, but okay, we've opened tunes.qbd. Now we hit the down key here, down to sort records, and enter, bang. Now this file, it's called tunes. Well, I created this database to keep track of, or to catalog all of my records, my vinyl and CDs and whatnot, which I've got hundreds, but here's just a list of a few, and we'll hit space to continue. Here's a few more. Now, we want to do is either sort ascending or descending, E or D, and we'll select A for ascending. Now we want to sort by index number, artist, title, year, or format. Let's just sort by artist here, so A for artist, enter, boom, and it's working. Now there we go. We have Asia, Boston, Captain Beyond, ELP, etc., 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 and all the rest down here. So we can, if we want, for example, let's sort ascending again, boom, by index, the number, or item number, if you will, working, and here we are, 1 2 3 4 5 6 7 index number. Let's try this, sort descending, and again by index, and you'll notice working. It's all backward. Number 22, Clat 2, Triumph, Hands. Well, 22, 21, 20, 19. You get the idea. We're sorting either ascending or descending by index, by artist, title, year, or format. So, for example, if we wanted to see, well, all right, let's just sort ascending by format. Let's see what type of records here. Now I've got 145 listed. I've got a CD and the rest are LP. Oh, I'm sorry, one MP3 for a band called Hands. But in any case, this is the idea. We can keep track of my records, and you could use it for your records if you like, or whatever items you want. But basically the idea is we're creating a database. Now, what are some of the functions of a database? Well, let's take a look here. We got open file, which we did that already. Now let's enter a record or two. Okay, so enter index. Well, let's see what. Hold on a second. Quit here. Let's sort records. Let's see. Sort by ascending. by index. Working. Alright, so our last record is number 22. So enter here to go back to enter records. We got 22 records, so now we want to enter index 23. Alright, and the artist will be Asia. Title Astra, their third album, great album. You got to check it out if you haven't heard it yet. Year, I think that was 1984. Format LP. And the notes, well, this is when Mandy Moore, excuse me, began playing guitar for them. So we'll put that in here. Boom. And then, well, one more, 24. Let's go Asia again. No, that's wrong. We'll just do this. Now, if you notice, I spelled it wrong, so we'll just do 24. This will overwrite the bad record that I just created here. So Asia, there we go, spell it right. Title, Aqua, A-Q-U-A, their fourth album. And this was 1993, I believe. Format LP, notes, nothing, and there we go. So now, if we open File, Tunes, bang, we go to Sort Records. And let's take a look here. We'll sort ascending by artist, and let's see what we get. There, Asia and Alpha, but now here's Astra and Aqua, the two records that we just added on there. Okay, what else can we do here? We can, we've opened the file, we enter records, we can delete records if we wish. We just, okay, let's go, let's see here, for sort records, what record do I want to delete? How about, okay, number 14, Boston, Don't Look Back. Okay, we go to delete records, and index number that we want to delete, number 14. Okay, now open file, tunes, sort again, and if we notice, yeah, only one Boston, Don't Look Back is now gone. So your typical functions of a database. Now this one's interesting here. What's the point of a database if you can't select certain parameters? For example, you want to see all of the records by, or all of the albums by one band, or all of the albums that came out this year, or everything on this format. So we filter records. Boom, here we go. Space to continue. That's what we have now. Let's filter by, say, artist. Boom. And Asia again. Now, there we are. Now, if you notice, these are records 1, 2, 3, and 4. And filter complete. Press any key to continue. Oh, save results to file. Yes. Now we're saving a file with nothing but... Oh, the file already exists. Overwrite. Yes. Boom. Okay, now if we go back to sort records... And we see, now 1, 2, 3, and 4 are rush, whereas with Asia, that's 23, 24, and the first two, what were they? The first two Asia were 7, 8, and the other ones were 23 and 24. But now if we do this, open file, Asia, opening file, sort records. Now you remember we had the, what was 7, 8, 23, and 24. In this file, this is a separate file now, just Asia, and the index number 1, 2, 3, and 4. Now I purposely changed the index number for this particular file because it's a whole new file. Why do we want numbers 7, 8, 23, 24? Plus, which I noticed before when I would just leave the numbers as is, number 7 would show up way down here, number 8 here, and in other words, I changed the number for the given record to 1, 2, 3, and 4. Again, because we're filtered out just the Asia albums, and here you can see there again, index 1, 2, 3, and 4. The artist, Asia, we got the title of the album, the year, LP, and notes for it. And enter to quit. Now we've opened the file, entered records, deleted. Oh, let's search for a record. Let's see, try this. Try a record, I don't know, maybe 9. See what that is. Boom, 9. Toronto, Looking for Trouble, 1980 LP, and that's their debut album. So again, the basic idea, we just we can open a file, enter and delete records. We can search one record, sort records, and filter records. Again, if we want to see just specific artists or specific years, what have you. And then finally quit. Bang. Alright, well, we have seen what this turkey does. Now let's see how she do it. Again, from the top, the typical header here, we got QBA33 base, DoodleBase by Dr. Doodle, copyleft 2025, and then the header, initialize program. All right, so next we hit type record and then end type. What we're doing here is creating our own data type, a custom data type, not just integer or long integer, floating point, string, what have you. We've got a record, which it's got 6 components to it, 6 members, as they say in the biz. We start with index as string times 7, so 7 numbers. Artist as string times 25 characters. Title as string by 25, year as string by times 5, format as string times 3, that's whether it's LP, 45, what have you, and then notes as string times 18. So, and type. Now, some of you, some of the sharper bulbs or brighter tools might have noticed here, I've got index as string. Well, index is the number. Why wouldn't I want to make it, say, an integer rather than string? Well, I'll show you. Just hang on just one second. Boom. Shell. Now, as I was working on this program, initially I set up the data type. I set the index member as integer instead of string. And, well, I'll show you what happened here. Let me just type. I renamed this wrong to show you what the difference is here. Enter. Now, if you notice, this is one of the data files. Here we've got Asia, Alpha, Astra, and Aqua. There are 4 albums. But instead of index numbers, look, what's a little smiley face here? And over here is another smiley face, this time white one. Then instead of 3, we've got a heart. Instead of 4, a diamond. And then, of course, clubs and spades and all the different. Well, what's happening is it's taking the index number, instead of just writing 1 or 2 or 3 or 4, it's using the index number as an ASCII character, and it prints the first ASCII character, which in this case is the smiley face. Character 2 is the second smiley face, the white one. Character 3 is the heart. 4 is diamonds. 5 is, I think, clubs, and then spades, etc. Well, that's all well and good. It works fine in the actual program. But keep in mind, there are only 256 ASCII codes. So what if I have 257 records? Then what happens? Well, I don't know. Not only that, but this is confusing. What do all these characters mean? Let's try this. Clear screen, and we'll type write QBD. This is when I changed the program to define the index as string instead, and boom, there we go. It actually, this is a string, it's not a number. So 1 is Asia, 2 is Alpha, 3 is Astra, 4 is Aqua, and so on. As you can see, the numbers are right there. Now, why is this happening? Well, let's go back to the program and I'll explain. Boom. All right, now here we are. If you notice, we are opening the file name for random, the random type. Now, when you open a random type file, for whatever reason, when you put data to it, it is always string. It's even if it's a number, it treats it as string. That's why when I would try to save the page up here, when I defined index as integer, it didn't care. It just took the integer number and used it as a character, the ASCII character, as string. So when you open a random file, even if you put numbers in there, the random always I guess it's the put function that treats your data as string data, whether it's numbers or whether it's string. So there's that. Okay, now let's start out here. We were typing, we type record, index again is string, artist, title, year, format, notes. Now we end our type. So we've created this data type, but we still have to define or dimension it in order to use it. So we dim record as record. Now this is a record as in like a legal record, not a plastic vinyl record, because some of these are CDs, some are 45s, etc. So they use the term record as a record of some data. It could even be data about cars or who knows what. So we dim record as data type record. Now we have our record type that we can use later on in the program. All right, width. Now we set the width of the screen to 80 columns by 25 rows, so we can squeeze more in there. You have to scroll, scroll, scroll. And next, on error, go to error handler. All right, so here is the error handler subroutine. And this is what called when a DOS error occurs. Now, what type of error might occur? Well, for example, if you're trying to save a new file and give it a name of a file that already exists, well, it's going to say, wait a second, that file already exists. So we bring up this error handler, you can decide what to do. First of all, we look at what the error number is, and this is a code that DOS returns to QBasic to tell, hey, this error has occurred. In this case, case 58, the file already exists, so you have to get some input. Input, file already exists, do we want to overwrite? And then we have a variable called OW for overwrite, $, because it's character. Now, if you case overwrite equals Y, yes, then kill a new file. That's the file that you're trying to overwrite. It gets rid of that. Name temp file QBD as new file. And abort equals 0, else abort equals 1, and if, and select, and resume next. So in other words, if you case overwrite is yes, then you want to overwrite it. So it kills the old file, it names the new file as the old file, and then abort equals 0 because it was yes, you did not abort. If it's no, then abort equals 1, and if, in other words, if you type yes, then you're not aborting this function. If you type no, you are, or anything else really, you're aborting this function. This is getting confusing, but we'll run through it a few times, you'll see what I'm saying here. So we've hit yes, means we want to rename the file. Abort equals no, we are actually renaming the file. Else, if we hit something else, then abort equals 1. We end if, and we haven't renamed the file. We're aborting this entire error handler, end if, and select, and resume next. Goes back to where you started in the code. So there's that. It's odd that I guess the syntax is strange, but that's what we're doing. We're looking to see if a file already exists. If it does, then we ask, do you want to overwrite it? If yes, we delete the existing file. We name the temp file as new file. That's the original, the name that we're trying to overwrite. Abort equals 0. We're not aborting, we're overwriting it. Else, if we don't want to overwrite it, then abort equals 1, end if, and select, and resume next. So that's the error handler, and if you happen to have a file already exists, well then it brings this up. So we'll go back to the top here. All right, on error, go to error handler. We just looked at that. Now the key function, key 15 in this case, what we're doing here, we're using the key function to create or define a user-defined function key. In this case, we're calling it 15. It could be any number from 15 up to, I think, 21. But we're defining it as character 0, which means no number lock, no control, no alt, just nothing else except for character 28, which is the enter key. So just enter, not control enter, not alt enter, not caps lock enter. Now on key 15 goes up enter, fittingly enough. That's the subroutine that handles it. And then key 15 on, that activates this user-defined function. So now the main program, we go sub menu. That's the menu that you saw at the beginning. Go sub down, that brings it down, because when we start out, the little character you saw there will be way up towards the top. We need to bring it down so it lines up correctly. I'll show you that as we go. Now do and loop. There's the end of the program. So what we do is select case in key. If case is H, character 0 plus H goes up. Case 0 plus P goes up down. And case character 27, that's the escape key system. So in other words, in this main loop here, we're selecting case in key. We got three options. There's H for the up key, P for the down key, and then character 27 is the escape key, which just ends the program. And select and loop. So the main program, all it does, it's looking for the up key, the down key, or the escape button. Now when we hit the up key, we go up, and then the P goes up down. That's the down key. Let's take a look at these subroutines. What we get here. Okay, here's the menu first. Now the menu just clears the screen, sets the color to 13, which is that kind of aqua color, and it prints all this out. Action menu, open file, enter, search, etc., etc., etc. After that, we go to color 14, which is yellow. We locate 5, 3, and print O, print F. In other words, it's printing the open, enter, delete, search, sort, filter, quit. All the first letters, it's making them yellow, just so they stand out a bit more. And then print Q for quit, Now locate 13.1, print select action and press enter. 14 again to make it yellow, this little header, this head of space. Locate and print A, print M for action menu. Long story short, the menu subroutine just prints what you see up on screen, all the various functions you can select. Here is the up subroutine. We start out, we locate opt. Now the opt is what option you want to do, whether it's open a file, add a record, delete a record, sort, whichever, option 1, 2, 3, 4, etc. So option +4, that just whatever selection you are, that brings it down 4 spaces because the menu is located down 4 spaces. So locate option, whatever option you selected, +4, down 4 spaces, at the first spot and print space. Locate op +4, 22 over to the right here and print space. That just clears out whatever's there. Now, option equals option -1. If option's less than 1, then option equals 1. In other words, suppose option happens to be 7. If you hit the up, then option equals option -1, it makes it 6, and the next time it calls, it makes it 5, then makes it 4, etc. If option is less than 1, then option equals 1, so it can't go below 1. We locate option +4 again to move it down to where the menu actually is. Print the right pointing character and then locate option +4 and print the left pointing character. These little, I don't know, chevrons I guess you'd call them, and return. Now, if you happen to hit the down key, well then you call the down subroutine, just does the opposite. Wherever it happens to be now, it prints these 2 spaces to clear out those chevrons. Option equals option +1. If option is greater than 7, then option equals 7. So let's say it was 2. Option equals option +1 is now 3. If it happens to be more than 7, it limits it at 7. Now it locates option, whatever option you've chosen, +4 to move it down with the menu. We print the right pointing chevron and then over here the left pointing chevron. Again, these just move the chevrons up and down, but it also sets the option to tell the program what you want to perform, what option you want to perform. Now we come down here and enter. Now if you remember up at top we set key 15 to the enter key. Now this first line, key 0 off, that disables the enter key. Now we are enabling our own function key, which happens to be the enter key. And it's hard to explain why I need to do that, but you need to do that. It's so that it treats the enter key the way we want to treat it. So in any case, we turn key off, key 0 off, which is the enter key. It's now defined as key 15, and it does what we want to do. So select case option. Case 1 goes up open file. Case 2 goes up enter records. Case 3 delete records, search records, etc., etc. As you notice, we select it up and down to move the chevron wherever we want it. And when we hit the enter key, this subroutine looks at, well, what is option? Is it 1, 2, 3? And then it activates or calls whatever subroutine is necessary to perform that function. Once it's performed the function and returned back to the, or completed what the subroutine does, now we turn key 0 back on, that's the enter key, and we go sub to the menu. So go sub menu, locate 4, +1 option, and you'll see that it prints the chevrons again. I don't know if that quite made sense, but just to go through it one more time, we turn key 0 off. Now that turns off the normal function for the enter key, and now it's recognizing the enter key as key 15, our function key. And we look at whatever option happens to be, 1, 2, 3, or 4, etc. And then it calls the necessary subroutine to perform that function. Now when we're done with this, we turn key 0 back on, so it treats the enter key as it normally does. Now we go to the menu, brings up the menu again, locate option +4, 1, print the right and the left pointing chevrons, and as above, so below. Basically, the menu prints this out. The up and down subroutines allow you to choose which one you want. Then when you press enter, it turns off the enter key and looks at what the option happens to be. And then it calls the corresponding GOSA, or subroutine, excuse me. Then it turns the enter key back on and brings up the menu again. If, for example, you hit case 7, go sub quit, well, that just ends the program. Now, come down here to the header. Again, pretty simple. Header, it just clears the screen, prints the index, artist, the title, the year, and if you look over year, format, and notes. Then this little line underneath there to like a header, I guess. Oh, yeah, header. It's a separator. Return color 14 and return. All that does is it prints that little header. Open file. Well, if we select was it function option 1, open a file. If option is 1, then we open a file, set color to 11, which is that aqua color, clear the screen. Now we shell dir.qdb. What does this do? Well, I'll show you what it does. We'll go down here and shell dir.qbd, enter, and there you have it. It shows the list of the QBD. For example, this is the tunes. That's the QBD, the database file that lists all of the different records I've entered already. Rush, Klaatu, Asia, Toronto, etc. Now all these, if you know, these are files that, for example, 18. If you look at 18, let's type 18.qbd, and this just tells you what record is. It happens to be hands. How about CD? Type cd.qbd. That's the one CD that I have, which is Moon Safari, or the one CD I've listed so far. How about type lp.qbd? And these are all the LPs that I've entered here. So basically what we're doing, we're shelling and type directory of all QBD so that we see what we can choose from. If we want to open a file, well, we need to know where there's an Asia file, there's a Boston file, there's Hope file, there's Triumph, there's Toronto, etc. So all that does, it brings up a list of what files are available to open. So we shell dir.qdb to take a look at a list of all the files that we have. Close any files that are open at the moment. With color 14, and we just print a space. Input, enter data file name. In this case, file name we're saving as a variable, string variable called file name. And that's where you type in, say, tunes or Asia or Boston, whatever you want to see. If length file name equals 0, then print no file found, retry. In other words, if the file doesn't exist, well, you can't open it if it doesn't exist. So we print no file, retry, no file found, retry, locate 10, sleep until you press a key, clear screen, and then go to open file. In other words, if the file doesn't exist, hasn't found it, so it prints no file found, retry, sleeps until you press a key, clears the screen, goes sub open file again. So back up to the top here. And this way, if you entered a bad file name, you can look at the list again and enter one that's valid. Now, if write file name for is not QBD, then file name equals file name plus QBD. I think we saw this with the last program, if you happen to see that video. What it's doing, it's looking for a file name, say Rush or Asia or Boston, what have you, Fly By Night, and looks at the file name that you enter. If the last 4 characters are not .qbd, then it tacks those 4 characters onto the end of the file. So if I just type Asia, well, there is no file just called Asia. It's called asia.qbd. So if I just type Asia, then it will automatically tack .qbd on the end. That way, all files are saved in the same format, same naming convention. And it's kind of foolproofing. So if you forget to add the extension on there, that adds it on for you. That's all that does. Now, print opening file name. Open file name for random is number 1. Length equals len record. Now, if you look here type record, here we've got index as string times 7. So 7 characters plus 25 characters. Title is 25, year 5. So 7 plus 25 plus 25 plus 5 plus 3 plus 18, which adds up to, I believe, is 83 bytes of data in each record. So when we go down here to length, where is it? Yeah, so when we go down here to open file name for random as 1, len equals len record, it's looking at the length of the record structure, I guess, which is 83 bytes, and it sets the record length to 83 bytes. So each time you add another record, it will set aside 83 bytes of disk space, because normally each record will be a 128 bytes by default. This way it's only 83, so we save space on the disk. Now, having done that, if you look here, we've got this little slop here. I wouldn't normally leave all these comments in here, but I wanted to show you this. This is a technique known as pseudocode that can be quite helpful. Let's say, for example, you want to do something like this, opening a new file, which with random files, it's quite complicated. It's a lot of steps. So what you might do is just write it out in English. What do you want to do? Well, the first step, we want to find the total of records. Next step, we want to dimension the temp array. And then the third step, we want to read file data. So you write out all the things that you want to do in pseudocode just to tell yourself, here's what I need to do next. Now we've got find total records, and so I need to write the code for that, which is total records equals length of file 1 divided the length of the record. Remember, we set the length of record to 83. So if we count it, if it's 83, then there's one record in there. If it's 83 times 2, I don't even know what that is, but there's 2 records. If the size of the file is records is 83 times 5, well, then there's 5 records in there. So we're looking at the size of the file, or the length of the file, I should say, that we just opened. Divide that by the size of each record, and whatever the number is, that's how many records there are. If it's 83 bytes times 2, well, then there's two records. Hopefully I've explained that well enough. Next piece of pseudocode, dimension the temp array. Well, we want to redimension temp records, total records as record. In other words, we're creating a new, or redimensioning an array that we've already used, called temp records, and the size is total records. So up here we've discovered how many records we have. Now we dimension a temp records array with the number of records that we have, and we dimension that as record type, instead of integer, instead of string, instead of floating point, whatever. We're actually creating an array called temp records. The size is set to however many records we have in the file, and then it's dimensioned as the type of record. Okay, next step, 3, read file data in the temp array. For z equals 1 to total records. Here we discovered how many records we have, so we're doing a loop from 1 to total records. Locus equals z, whatever it happens to be. It starts out as 1, and then 2, and then 3. Get one locus record. In other words, we're getting from file number 1, whatever location, whether it's the first time through, well, the first location, the second time through, the second location, third time through, obviously third location, and we're getting a record from the file, putting it into the temp records array. So temp records z equals record. Here we get the data from file 1, and we define that as record. Now set record z equals record. We're setting it to the array, loading it into the array, I should say. Next, z and sleep 1 return. So we go through the loop. For each record, we read a piece of data from the file and put that in the temp records, wherever it happens to be, z, etc. Then we sleep 1 for 1 second and return. So here we've opened our file. First off, we took a look at the files that we have. We closed any open files. We got input, what file do you want to open? We validated that. Does the file exist or not? And once we got a valid one, we look at the name they put in. If it doesn't happen to have the QBD extension on there, then it puts it on there. We open the file. Now we're looking, open the file name for random. We're opening this file that already exists, and the length is set to the size of each record. Now we find how many records there are, dimension the temp array to hold the records, and next we go through a loop to put each record from the file into the array. Boom, our file is now open. Next, enter records. All right, so here we are, enter records. We've opened our file. Let's say, for example, tunes. If we've opened our file, we clear the screen. Now we go into our loop. Each time through the loop, it clears the screen, locates and prints enter index, enter to quit. So it's asking what index number you want to add to this data file, and just press enter to quit. Locate 134, input record index. Now we're setting the index member of record to whatever is input here. So if let's say you want to enter record number 37. Well, record.index now becomes 37. If the value of record index is less than 1, then close number 1, open file name for random as 1 length record, and exit 2. In other words, if you hit the enter key instead of entering an index number, then input nothing basically, and the record is in record.index is set to nothing. So if val record.x is less than 1, then we close 1, close the main file, reopen it so that we can work with it again. It basically refreshes it. Reopen the file for random as 1 length record, and exit 2. We're done with entering records. And if. Now, if it turns out that you do enter a number, 17, 18, whatever, then locus is set to the value of the record index. That's the number you just entered, number 17. We input artist, and whatever you enter, Asia, Boston, Triumph, Klaatu, whatever, that is assigned to record.artist. Now we input the title, record.title, the title of the album. Input year, record.year. Input format, record.format. Input notes, record.notes. Now we've got all our 6 members for our record data type, the index number, artist, title, etc. Now we put 1 locus record. If you notice, we don't have to put this, put this, put this, put this, put this. Our data type is filled. We just put 1 full record with all the members in one shot. Put 1 locus record. So again, if we was 17, well, locus is now set to 17, and it puts that record at location 17. Now we loop until you hit the enter key. If you remember, if we hit enter up here, record index equals 0. So if record index is less than 1, then close and exit 2. Now, suppose we do enter record 17. And we loop back here to enter index number. Maybe we want to enter another record. If we do, we'll put in 18, and then after that, 19, whatever. When we're done, we just hit enter. This if statement here checks, they've just hit the enter key because index is set to 0. Exit 2, you're done, and return. Hopefully that was clear enough, but the idea is that you clear the screen and you ask the user for an index number, index 1, 2, 3, etc. This is where you get the actual number and set that to the index. Record.index is set to the number that you just entered. If the entered happened to be 0, well, that's because you hit the enter key and it just exits the subroutine. You're done. If not, then locus is set to the value record index. That's the number that you entered for record 17, 18, or whatever. We input artist, record.artist, record.title, etc. We get all the different members for our data type. Once we got all our data, we put to file number 1, the file that is open now, wherever location is, locus, the 5th record, 6th record, etc. We put record, all this data in one shot, boom, goes into the file. Once we're done, then we just open the file name for random as 1 and then return. Now, come down here. Alright, now we've entered all our records or sorted or filtered, whatever we want to do. Now we decide we want to delete records. So what we're going to do is simply put is we're going to open a temporary file called delete.qbd. This file will hold a copy of every record in the file except for the one that you want to delete. So we start out here, clear screen, print delete records. First of all, we open a temp file. You see here, temp file, close number 2. That's if you happen to have a second file open, it closes it. Open delete.qbd for random as number 2 length record. So we've opened a new temporary file called delete, ready for data. Now we select a record, locate 1, input, enter record to delete, or enter to quit. Locate 141, input the index. This is where we get the actual index number. Now search for record delete. For Z equals 1 to total records. It's going to look through the tunes QBD file, look through all the different records, and get 1 Z record. Now, if Z is not equal to index, then, if in other words, let's suppose you want to delete, say, the 5th record. Well, here we're setting index to 5, because that's the record we want to delete. Now we go through the loop, and if get 1 Z record. If Z is not indexed, which happens to be 5, then print record, index, record artist, record title, put to record. In other words, if Z, the record it just got from the file, does not match the index that you're trying to delete, then it prints out the index number, the artist, and the title, and then it puts that to number 2, file number 2. It goes through each record in the original file, and if it is not the one that you selected to delete, then it copies it to file 2, which is the delete.qbd temporary file. And if, next Z. So it just goes through record by record by record, looking at this file. What's that record number 1? Okay, we'll copy that to delete.qbd. Record number 2, yeah, we'll copy that. Record number 3, we'll copy 4. Oh wait, 5, we decided we want to delete 5, so we skip it. Now we go to 6, yep, copy that to file 2. 7, copy that to file 2. So in other words, we will have a copy of the original file called delete.qbd. Now we close 1 and close 2. Kill the original file name, name delete QDB as file name. In other words, if we had tunes.qdb open, this deletes tunes QDB. This renames delete.qdb as file name, renames it to tunes. We delete the original file, we take our temporary file and rename it to the original file name. It's kind of a tricky way of doing it, but so what we've done, we create a temporary file. Now we look through the main file, and if the record number does not match the index that we decided we want to delete, then it copies it over, copies it over, copies the next, copies the next, copies the next. If the Z, the record we're on, happens to match index, that's the one we want to delete, then we just skip, we go on to the next record. Once we've done that, we now have a copy of tunes minus the record we want to delete. Now we delete the original file, the whole file. We rename this to match this one, tunes.qbd, and there we go. We've effectively deleted one record from tunes.qbd. And again, rewatch this if you didn't quite follow, but that's what delete does. All right, now the search record function. This is a relatively simple one. So suppose, for instance, you've looked at a large database that tunes. Maybe we've entered hundreds of different records in there. And we were forgetting, oh, which one was number 117? Which record was that? Well, we go to search record, clear the screen, go subheader, which if you remember just prints the index number, artist name, record, album number, name, the title, album title, the year, the format and stuff like that. It just prints that at the top. Now we locate 1-1 and we print search for index number, enter to quit. So again, 115, we input record. Now record now becomes, or rec, now becomes 115. We print space there to clear that out. Now if rec equals 0, then return. In other words, if we just hit enter, then rec is 0 and we return. Now we set locus to rec, whatever it happens to be, 115 that we just entered. Now we get from the main record, tunes.qbd, locus, so record number 115, and we put that into our record data type. Now we locate 6 and 1, so 6 rows down, first column, and we print the record index. We bring it down 6 because the header is up there. We don't want to print over the header, so I move down 6 rows, and we print index to 1. Locate 614 over here, and we print record artist. And then we look 630 over here again, print using record title. This here we've talked about print using in the past. Basically, it's just formatting how it's going to print the title. So it's only these many spaces. If the title is that long, it doesn't care. It just prints that many characters. So we locate 6 rows down, 30 over, and we print the record title, the first that many characters of it. Now we locate 6, again 6 rows down, 46 over, print the record year, and then the record format, record notes. In other words, we're going down to the 6th row, all these locations, we print the record index, record artist, the album title, the year, the format, and notes. Now we sleep until you press a key, and loop while rec is greater than 0. So if there's another record that you want to check out, maybe 120, then it loops back to the top. It does the same thing. First we clear the screen, go subheader. Now we locate print, search for index number, whatever record you happen to want to see, 120, 180, whatever. Enter to quit. locate and input the rec, that's their temporary value. Locate 137, print, clear that space there to clear it out. Now if rec equals 0, then return. In other words, if you just hit the enter key, return. Locus is equal to rec, that's the number you just entered. Get from file 1 whatever record you just entered, 115, 120, and we save that to our data type called record. Now we move down 6 rows, so underneath the header, locate the first column, print record index, 14 columns over, record artist, the artist name, 30 columns over, the record title, and then the record year, format, and record notes. We sleep until you hit a key, and then loop while rec is greater than 0. In other words, if you haven't hit 0, it just keeps entering different, like maybe you wanted to search, I think that Asia's Astra album is number 17, so I'll search 17. Oh no, well maybe it's 18, I'll search 18. Yep, it was 18. This just allows you to search through the records that are there for a specific record and get the information from it. Again, pretty simple. That's all there is for search. So let's take a look down here at sort. Alright, so here we are at the sort subroutine, and this is the big mama here. This is the where the nitty gets really gritty. This does all the heavy lifting, most of it anyway. Now, if you are one of the 26 people on this planet who saw my last video about the bubble sort, this should be a little clearer to you, but we'll try and go it slow, step by step, and hopefully you'll understand. And you may want to look at the last one, that'd be QBA33. What sort of QBasic madness is this? Talking about the bubble sort. But here we're going to go through and actually sort it, either ascending or descending. We're going to sort by artist or by title or index, what have you. There are 4 main steps here. The first is to display the current record order. Then the second is getting sorting options. Do you want to sort ascending, descending, by artist, by year, what have you. Then we perform the sort operation itself, do the actual sort. And 4 is display the results. Okay, sounds simple enough, so let's go through it line by line. Okay, we close number 1, open file name for random as 1, len equals len record. Now, in other words, we've got file name open, we close it, we reopen it just to refresh it in the memory. Now we display the current record order. We go sub the header to print all the index, the artist number, name, and the record number, all this stuff. Now we go sub show table. And in a nutshell, show table just prints out all the individual records. We'll take a look at show table a little bit later. Now, do get sorting options. Here's a line label, retried AD for ascending, descending. What this is, it's going to ask, do you want to sort ascending or descending? If we put in an invalid character, then it just loops back here and try again. Basically, retry AD. So color 13, locate 23.1 and print sort ascending or descending. A or D, enter to quit. So it's asking, do you want to sort ascending or descending? Color 14, locate and print AD. Locate 2351 and input AD $. So this is a string character for 8 called AD, and we set AD to UCase AD. In other words, inputting AD for ascend or descend. Then we're taking AD and we set it equals to uppercase AD. So if you happen to hit a lowercase a or a lowercase d, this sets it to uppercase A or uppercase D. Now, if AD equals A, or AD equals D, or AD equals nothing, then nothing. Else, print invalid entry, try again, and go to retry. In other words, if you happen to enter A or D, or just the enter key, then it continues on. If not, then else print invalid entry, try again, and go to retry AD. So if you happen to hit R, well, AD is not equal to A, AD is not equal to D, AD is not equal to nothing, so we go down to else, print invalid entry, try again, go to retry AD, and if. Now, if AD equals that, then return. Simple enough. Now we've got retry cat. This is the same as that retry AD. We've selected whether we want to sort ascending or descending. Now we're selecting the category. Do we want to sort by item? Do we want to sort by artist? Do we want to sort by title, etc.? So retry cat, if we put in an invalid entry, it'll come back here. So color 13, that's again the aqua color. Locate, print, sort by. Index, artist, title, year, or format. And now we color 14, which is yellow. Locate, print there, and print I for index, A for artist, T for title, Y for year, F for format, and yeah, does that highlights the index, artist, the I, the A, the T, the Y, or F, highlights them in yellow so you can see what your selections are. Now we locate 2348, input cat, and again with the $sign, that's a string variable. Now we set cat to UCase cat, whatever character you put in, whether it's I, Y, T, that's it to uppercase. Now we can sort through it. So if cat equals I or A or T or Y or F, then again, don't need to worry about it, it's valid. Else, if you've entered anything else, invalid entry, try again, go to retry cat, end if. So now we have got our options. We decided whether we want to sort ascending or descending. Then we decided what category, what particular piece of information we want to sort by. Now we perform the sorting operation, okay? And this gets ugly, but here we go. Print working, because it knows what to do now and it's working. For reps equals 1 to total records. So it's going to look through all the records. S equals 0. We'll get to what that means next. For sweep equals 1 to total records. -1 minus S. Select case AD. So it would select whether we're sorting ascending or descending. And if case happens to be A, then we select case cat. So we're sorting ascending by item or by artist or by title or by year or by format. If case happens to be D, then the same thing but with descending. So here we are, we selected A, we select category, say for example I for item number. If value temp record sweep dot index, that's the index it's currently on, is greater than val temp sweep plus 1, then swap them equals 1. In other words, we're looking at the value of the index for the first record and compare that to the second record, record 1 plus 1. If it's greater than val records 2, then swap equals 1. In other words, we're doing ascending. So if the first record happens to be 2, the next record is 1, well that's in the wrong order, so swap them equals 1. Now, A, if temp record sweep artist is greater than temp record sweep plus 1, the next record artist, then swap them equals 1. If temp record sweep title is greater than sweep plus 1 title, then swap them equals 1. Again, for year, if the year for this record is greater than the year for the next record, then swap them. And same with format. We swap as necessary. Case D, if we're sorting descending. If case I, the index number for the current record we're checking, is less than the next record, then swap them equals 1. If the artist is less than the artist, then swap them. I guess in simple terms, all we're looking is for something that's out of order. And if either the item number is out of order, or the artist name, or the title, or the year of the format, then swap them equals 1. Otherwise, just ignore it. So end select. We've gone through and checked all our items, and if turns out swap them equals 1, then swap temp record sweep plus 1. So if it turns out the index is out of order or the artist is out of order, then we swap the current record with the next one to put them back in order. Swap them is now set to 0. S equals S plus 1. Next sweep, next reps, sleep 1. What is the arrow? Okay, swap equals 0. We set swapping back to 0, so the next time through it's already set to 0 and it stays that way unless we have some reason to swap. Swap equals 1, swap equals 1. Now, s equals s plus 1. That tells us that we've already gone through one sweep. The next time through, s equals s plus 1, so we've gone through 2 sweeps. We've gone through 3 sweeps, 4 sweeps, etc. And what we're doing is up here, right here, for sweep equals 1, 2, total records, minus 1, minus s. So in other words, the first time through, sweep equals 1, the total records minus 1. You can't check the records plus 1. If there's only 10 records, you can't check record number 11. So we're going from 1 to 9. Now, so we subtract s. So the first time through, the sweep is 0. So we're checking all 10 records. Next time, s is 1. So now we're, instead of checking 10 records, we're only checking 9 records. S is now 2. So now instead of 10, we're checking 8 records. Next time, 7 records. Because we've already sorted the first few, we don't have to sort them again. It's just a way of optimizing the sort. Instead of having to sort all the records every time, if you've already sorted the first record, you don't need to sort it again. So you start with the second record. Or if you're descending, if you already sorted the last record, you don't need to sort it again. You go to the second last record. Hopefully that makes sense. But the idea is we go through the records sweep by sweep by sweep, sorting each pair of records. And if they're out of order, either because they're ascending or descending, then we swap them. Now we go through the whole list again, and we start, instead of going through the whole list, we go through the whole list minus 1 sweep because we've already sorted one of them. Next time through, we've sorted 2 of them, so we'll only go through 8. Next time through, we've sorted 3 of them, so we'll only go through 7, or however many records you have. Hopefully that makes sense. Just watch this section again if you need to. But the idea is it goes through, and if for any reason something's out of order, either it's ascending when it should be descending or vice versa, if the item's out of order, the title of the thing is out of order, then it performs the necessary swap, goes back and goes through the whole list again until there's no more to swap. And now we're done. So we sleep for a second. Let me catch my breath. And now we display the results. Go sub header, which prints the header up top. Go sub show table, loop, and return. Whew. Okay. All right. Next up, we've got the filter records subroutine. This is where, if you remembered earlier, we spoke, let's say we want to see only records from a specific artist or a specific year or a different format, what have you. We'll go through the entire list of records we have in the main file. Let's suppose it's tunes.qbd, and whatever match our filter parameters, it sorts them out and sends them to a secondary file. And well, here we go. We start by opening a temporary file. Then we get our sorting options. What do we want to filter out here? We perform the actual filter function. We write that to the file. We close and then print the file filter report, show table, and return. So if you notice, I'm not using pseudocode for all these steps here. But first off, we open a temporary file. Well, that's easy enough. Do. This is the start of the whole subroutine. We may want to filter 4 or 5 different items, but we do the loop. We set Z to 0, locus 0, R equals 0, hit equals 0, and yes, no equals nothing. So we close number 2, in case we happen to have a temp file open. We close it and open temp_file.qbd for random as 2 with a length set to the length of the record. Now we get our sorting options. We go sub header, go sub show table to show all the records that are in there currently. Retry filter, just like the retry AD, retry cat. If we enter something invalid, it comes back to this line label right here. Color 13, you'll see a lot of repetition here. 13, that's the aqua color. Print filter by index, number, artist, title, year, or format. Then we go down, locate 14, and this is now the color is yellow, so yellow F, yellow, or I'm sorry, yellow index, yellow A, yellow T. The first letter is yellow, so it basically highlights what your options are. Okay, locate I, A, T, Y, R, F. Now locate 2366 and input cat. We're selecting the category, which is stored in cat $, so cat character data. We're inputting the cat character variable. Now we take that variable and set it to uppercase. So we're either uppercase, whatever, I, A, etc. So we locate 2366, input cat, that's cat string variable, and now we take cat for category string variable, we set that to uppercase. Now we perform our filter operation. Select case cat. Case nothing, just return. You're done. You don't want to do anymore. Case I, case A, case T, case Y, case F, and now here case else. This is invalid, so we print invalid entry, try again, sleep 1 second, and go to retry filter. So we'll assume we went through the input, we got a valid category. Now it's time to perform the actual filter operation. So we select case cat. If case is nothing, that means we hit the return key, so we just return, we're done. If case is I, index, now it inputs index number and stores that in variable Z, excuse me. So for example, you want to look at, I don't know, number 17. Now new file is equal to mid string Z2. What does all this mean? Well, we've saved Z as a number, but we need to come up with a file name, new file name. But for that, we need not a number, but we need a character. So SDR turns the number 17 into a string representation of 17. Okay, so instead of having the number 17, it has a string, quote, 17, more or less. Now, mid takes a certain portion of that, in this case, the second position, not the first, but the second, and anything after that. In other words, it strips off the leading 0. Basically. So str converts the number you type, 17 to 18, 19, whatever, into a string version of that number. Mid strips off the leading 0, and now we stuff that into new file. That's the variable that we're going to create a new file, and that's the name it will have. Now we go some header to show the header. We've seen this many times. We'll assume, since we know exactly what index number we're looking for, we'll assume hit is equal to 1. We've had a hit. Now if Z is greater than total records, then hit equals 0. In other words, if there are 10 records and I enter 14, well, that's no good because there isn't a 14th record. So if Z is greater than total records, then hit equals 0. Do nothing. Now, if hit is 1, then go sub print filter report. And we'll see that a number of times. Let's assume case A, we're sorting by artist instead of by index. Well, then we enter artist, we get the artist name, new file, set the artist. So if we're sorting by artist, we'll create a new file called artist. In other words, if we're sorting, say, by artist and we enter Asia, we'll create a new file called Asia. If we're sorting by artist and we enter the name Toronto, well, it'll create a new file called Toronto. Now, artist equals artist plus all these spaces, add 25 spaces on there. Artist equals left artist, 25. Artist equals UCase artist, and goes to header. Now what's happening here? Well, let's suppose you're searching by artist and you want to look for Asia. You enter Asia. That's 4 characters. So it's going to search for 4 characters, but it will never find 4 characters because on disk the artist is stored as 25 characters. That would, in other words, if you're searching for Asia, it's looking for Asia plus 21 spaces, but you've only entered Asia. So we take Asia and we add 25 spaces to it. Now, artist equals left artist 25. In other words, we've got 4 letters, we add 25 spaces, so that's 29 characters altogether. Artist equals left artist 25. We shortened it back to 25 spaces. And artist equals UCase artist. So if you just enter 4 letters Asia, it's never going to find it because it's looking for Asia uppercase plus 21 spaces for a total of 25 characters. Hopefully that makes sense. It wants to, on the disk, the artist name is stored in uppercase and it's 25 characters. Even if the name is only 4 letters or 5 letters, it's got that many spaces after it. So we take the artist name, we add 25 spaces, we use left to find the first 25 characters, which is Asia plus, 21 spaces. Artist is uppercase. So now at the end, if you type in Asia, it's looking for uppercase ASIA plus 21 spaces. In other words, it's just formatting what you enter so that it matches what's on the disk. Hopefully that makes sense. If not, I don't know how else to spell it out to you. But in any case, once we've done that, we go subheader. Again, you've seen it. It just shows up on the screen, all the characters. Now for Z equals 1 to total records. If UCase record Z artist equals artist, then hit equals 1. So in other words, it searches through, and if the record, temp record Z, if that particular record happens to match the artist that you've entered, then hit equals 1 and go sub print filter report, which we'll look into that in a moment. Next, Z. So it's going through every record, and if it matches the parameter that you've entered, like maybe there's 4 Asia records, it goes through from 1 to 2 to 3 to 4, and if the temp record Z artist exactly matches what you entered, then boom, there's a hit. And we go to print filter report. Next, Z, keep going through for the entire file. Each time there's a match, boom, it filters it and puts it in the next file. Again, same with title. New title equals title. That's the title that you enter. Title equals title plus 25 spaces. Title equals left title 25. So again, if the title happens to be, I don't know, well, with Boston, don't look back. I don't know how many characters that is, but we add 25 spaces onto the end, so maybe it's 30 spaces 30 characters altogether. Now we look at the first 25 characters, and the title is converted to uppercase title. Now, the title happens to be Don't Look Back, with however many spaces afterwards. Now, for Z equals 1 to total records, if UCase temp record Z title happens to enter the parameter you just entered, then hit equals 1 and go sub print filter report. Again, we're just going through by category, whether it's artist or title or year or format. It's adding the spaces on the end, cutting it back to 25 spaces because that's the size on disk, and that's what it's searching for. Okay, now do the same with the years. Do the same with format. If you happen to find an exact match, then go sub print filter report, print filter report. Case else, print invalid entry. We saw that already. Now, if hit equals 0, locate 5.1 print no match found, please retry. In other words, if it's gone through the entire file, found no matches, there's a problem, retry. Locate 23.1, color 13, print filter complete, press any key to continue, sleep until you press the key. Now, input, save results to file, yes, no, and Y, and if that's yes or no, character. And again, we convert the character to uppercase YN. If you remember, earlier, if you try to save a file that already exists, then it goes to the error handler. But here we're asking, do you want to save results to the file, yes or no? If yes, no equals Y, then go sub right to file. And we locate, print, this is locate row 24 to 5 to 27, print all these spaces just to clear out that part of the screen. Loop back to the beginning and we're ready to start again. Okay, so that's it for the filter. I know it makes very little sense. Working with random files is a lot of work, but again, the idea is we open a temporary file, and that's called tempfile.qbd. So do for each record that we want to filter out, we set our variables to 0 and nothing. We close number 2 if this file happens to be open, and reopen it for random as number 2. Now we get our sorting options. Do you want to sort by item number, index number, or by artist, or by title, etc. We perform the actual operation. This is the part that gets icky, but just again, we select case. What do you want to sort by? If it's by nothing, we've hit the return, we're done. If it's by index, we just look for that index number, and if it matches, we go sub print filter report. Now, if case artist, we enter our artist, we format it to what matches the disk, go sub header, and for Z equals 1 to the total records, it's looking through the entire file here, and if it finds an exact match, then hit equals 1. So maybe the first one's a match, next 5 are not, number 6 is a match, next 2 are not, number 9 is a match. It goes to sub to print filter report. Goes through the whole file, and then it prints, go sub filter report. We'll look at that in a moment. Same for the title, same for the year, same for format. Case else, if you've entered some invalid like R or L, well then it goes back to retry. If hit equals 0, there's no more hits left, or you didn't find any matches to begin with. It says no match found, please retry. Locate 23, print filter complete, press any key to continue. Now we sleep. Once we hit a key, it asks us, do we want to save results to the file? Yes or no. And if yes, then we go sub right to file. We clear out the spaces here on the screen and go loop through with the next filter, next filter, next filter. Now, right to file. Oh, this is another icky one. We start out by parsing the file name. The parser code strips off the first 8 characters, replaces spaces with underscores, and adds a QBD extension. So text is set to nothing. Now for Z 1 through 8, we can only have 8 characters in a file name. So character equals mid, file name Z1. So we're looking at the first character, 1 character at a time. And if that happens to be a letter, a number, whatever, we're good. If that character happens to be a space, it replaces it with underscores. If the character is nothing, then we're done. In other words, if the new file name is Asia, just 4 characters, that's all we need. We take the 4 characters and we add the extension. If the character happens to be a period, then we go sub skip. We can't have periods in there. Like an abbreviation, Emerson, Lake and Palmer, E period, L period, P period. Well, that won't work because you can only have 1 period in a file name. So this would strip out the periods, and E period, L period, P period would become ELP. Hopefully that makes sense. You're looking through each character in the file name one by one. If it's a space, you replace it with an underscore. If it's nothing, you're done. There isn't a full 8 characters, so you just add the extension. If it's a period, you just skip. Now text equals text plus character. And then we skip here, go to skip, next Z. When we're done, we take text, and when their new file name equals text plus QBD. So hopefully that makes sense. Now we close the file. Name temp file QDB as new file. This is the temp file that we stored all our results in. We take the new file name, Asia, or whatever year, whatever format, and we change temp file to this name. If abort equals 1, then return. If remember, we went to overwrite. If we don't want to overwrite, then abort equals 1, so return. We're not going to save it to file. Now, assuming that abort equals 0, we kill temp file QBD, print report file saved to file, new file, sleep 1, and then return. Whew, that was a lot. Now we go to print filter report. If you recall, whenever there's a hit or a match, we call print filter report. R equals R plus 1. So row plus run, we go down the screen, and we're just printing the results of that hit. hit R equals R plus 1, locus equals locus plus 1. Now, if R is greater than 20, then go subheader, R equals 7. Go subheader, that'll clear the screen, move R back up to 7, row 7, and continue going. Because if, let's say we get down to 20, and we try and print locus, it'll print locus. Now we print temp records, locus will go up 1, it'll print temp records. Now we print temp records title, it'll go up 1, it'll print the title. Now we print the year, they'll go up 1, so you get it going down like this. You cannot print lower than 20 rows, or else it'll make the screen roll up, and you don't want that to happen. So if R is greater than 20, then go subheader, clear the screen, set R back to 7. Now we locate R minus 2, and first column is print the locus, that's the item number, keep saying item, I mean index number. Locate R minus 2, 14, print temp record artist, so that it prints for the first hit, it prints the index number, the artist, the title of the album, the year, the format, etc. Now there's another hit. Maybe it's item 17. If we go down to one more row, R equals R plus 1 is now 2. So each time there's a hit, it moves down a row and prints all the information for that particular match. So having done that, time 1 is set to timer. Now let's take a look at the timer function. Hang on a second. Timer returns the number of seconds elapsed since midnight. Use timer to time programs or parts of a program, or with randomized statement. So, escape. Alright, what we're doing here is we're setting time to whatever the timer happens to be, however many seconds past midnight right now. Now we do time 2 is set to timer. And we loop until time 2 is greater than time 1 plus 0.25. So we set time 1 to whatever the time is. Now we're looping. And we keep setting time 2 to the timer. Time to the timer. We'll keep looping until time 2 is greater than the original time plus 0.25 or quarter second. If there was 50.5, then it will loop until it's greater than half a second, etc. We do this because with sleep, you can only sleep 1 second, or 2 seconds, or 3 seconds. But I didn't want to wait a full second between hits. It would just take too long. So this line here just delays for a quarter second after each hit. So you can read it, and then it prints the next one, and it prints the next one, prints the next one. That's all it does. It's a delay. All right, now, next up we got temp record z.index equals str locus. What's happening here? Well, if you recall earlier, I mentioned sorting out records that had to do with the band Asia. Now, if the first record for Asia was 2, the second was 8, the next was 12, whatever, it makes no sense to have these index numbers in a brand new file. You want the first record that you find to be index 1, whether it's number 17 in the original file or 35 in the original file. So what we're doing here is we're taking temp record z.index and setting it equal to string representation of locus. Now up here you see locus equals locus plus 1. So the first time through it's 1, the next time it's 2, next time it's 3. The first match, for example, would be locus 1. And so we now set the index of this match to 1 because it's the first match that we found. And now we put the file to locus, in this case 1, temp record z. That way what happens is the first match that we find is labeled as 1, and we put in record 1 temp record z. That's all the information, the year, the format, the notes, artist, etc. Now we search through, I don't know, 20, 30 more records, and we found, oh, here's another one with Asia. So let's see here. Locus equals locus plus 1 is now 2. We take the information here, and we set temp record z index to 2 now, because locus is now 2. We put file to locus, number 2 now, temp record z. In other words, we're just setting the index number of each match, each record we're filtering out, to consecutive numbers, 1, 2, 3, 4, 5. Once we've done that, we return, and so much for a filter report. All right, now we come to show table, which we spoke about earlier. We set R to 1, row to 1. For Z equals 1 to total records, so we're going through every record in the file. And if Z mod 18 equals 0, then, in other words, if you come down 18 lines, then color 13, locate 23, 1, print, press space to continue. So it prints press space to continue down here. Sets color back to 14, which is yellow. R equals 1 again. And we sleep until you press space, of course. Now you go to go sub header, which header clears the screen, and it prints the titles and the items along the top here. Moves R back up to 1 and starts printing up here again. In other words, when we get down this low, if we print the next line, the whole screen rolls up. We print the next item, the screen rolls up again. The next item, the screen rolls up again, etc., etc. And you get this sloping kind of display. It looks ridiculous. So if it goes down that low, then we go we print, press space to continue. We sleep and wait until you hit space. Then we go sub header, clear the screen, and set up the title header information up here. Then we go on to the next match. It will be 19, 20, 21, 22, etc. So that's if we get down to 18, we do all of that. If not, then we locate R plus 4. So it would be if Z is 1, then R plus 4 is 5, row 5. Print using temp record index. Right next to that would go to the artist, and then the temp record title, the year, the format, notes, etc. So this would be row 5, and the next match that we have, it goes down to row 6 and prints the same stuff, etc., etc., etc. When you get to the end of the file, then it just returns. So basically what this does is just shows every match that you find, and if it gets down too low, instead of rolling the screen up like that, what it does, it goes to go sub header, clears the screen, and starts over at the top. That's really all that show table does. Alright, so moving on, what do we got here? Not too much. Oh, well, quit's pretty simple. Quit, close, clear screen system. Easy enough to figure out. It just ends the program. Now we got the error handler, which again we spoke of earlier. And if you happen to have an error, for example, the file already exists, then this error handler comes up. So we go select case error, and case 58, that's the case of the file already existing. We input file already exists, overwrite, and then OW for overwrite. If ucase OW equals yes, Y, then kill the new file name, name temp QBD as new file. So if the file already exists, we want to overwrite it, so the new file name, we get rid of it, delete it, and rename temp file QBD to new file. Abort equals 0. Else, abort equals 1. And if, and select, resume next. So in other words, if you press Y for yes, you want to overwrite, it deletes the original file, renames temp file.qbd to the whatever name you came up for this file. Abort is equals 0. If you press no, then abort equals 1, and it does nothing essentially. And if and select, resume next. And if you notice below here, I've printed out, this is from the help screen. These are some of the, where was 58? Yeah, file already exists. Or next without for, return without go sub. These are some of the errors that DOS can send to your program, and you can deal with them if divide by 0. Oh, you could let the user know, hey, 0 is not a valid number to divide by, type mismatch, etc. So any case, that should just about do it for the code. Finally. Alright, now that does it for the code, so we'll go on to the Supeeriors. I got a great one this time. Young lady by the name of Ali Spagnola. I've actually really recently found out her not too long ago, but wow, she's pretty amazing. Hang on a second, we'll do the Supeeriors section, then we'll bring this back and wrap this pig up. Send you on your way. Hang on one moment. Supeeriors! Alrighty, gang, well, here we are at the YouTube channel of Miss Ali Spagnola. This woman's amazing. I have to admit, I'm a relative newcomer to her channel because my buddy Eric, I got to thank him for turning me on to her, but she is just outrageous. Just like it says, outrageous art, outrageous music for outrageous people. Well, she is outrageous people. The crazy things she comes up with. 2.5 million subscribers, almost 2,000 videos. There's plenty to see here, but wow, I cannot just 2,000 videos. We can't scroll through them all, but just incredible stuff. I'll hit the some of the ones I've watched recently is I don't know if you've seen the Skibbity toilet deal thing. A guy popping his head out of the toilet. It's a cartoon.
This looks insane.
It's popular.
I look insane. I am going insane trying to make this work.
Hey Best Pally, I'm Allie, and I like to make iconic artwork. So today I am making a life-size version of the timeless Skibbity toilet. If you don't know what Skibbity toilet is, you are not alone.
Yeah, so she ends up making a full size. She takes this. Look at this. She's got this foam head that she covers in clay, and she's modeling it to match the match the cartoon. It's just crazy.
Center.
She gets him in the thing there.
As I get it in.
Where is it? Eventually, she gets the thing put together and it actually rotates.
Making this easy. Please, just do it.
There we go. Oh, well, it started anyway. But by the end of it, she gets the thing working and Skibbity toilet. I don't know how else to explain it. That's just a small sample of what's to come here. The crazy things this woman does. It's just amazing.
Okay, that's good. That's very good. Now this has to go perfectly level inside. Please.
There he is. Okay, so there's one of them. What else? She made a lifetime. This is a skull, a life-size glass skull that she had, well, acrylic skull with a light bulb inside, and it actually lights up. Let's see if I can.
It's crazy.
I don't want to ruin it for you, but let's get to the end here.
I know, I'm neat. I guess we have to be able to turn it off. It's okay to be out of ideas sometimes. I am so excited.
There you go.
It looks incredible already, not even in the dark. The shadow is so cool. Alexa, give me an idea. It worked! My idea worked!
Who thinks of this? I mean, come on. Tell me that's not outrageous. What's next here? We got, the fully velvet car. I haven't seen all of this one, but...
It's velvet. No way. Wow. Hey Best Pally, I'm Allie, and let's make a freaking...
Come on. There's her car. Was it the little Tesla? I think it is. I don't know. Of course, this internet's slow here.
Much harder. Absolutely getting it on my windshield and need to fix that.
Get to the end here.
Just driving the Jaguar around, you know.
The Jaguar.
Hey. Here and see if I can get someone to come out and appraise my vehicle. Hi. Good. You work here? I'm
We're
Allie.
in a Jaguar outfit.
Nice to meet you. You want to come take a look at my Jag?
Yeah, it's big.
Okay, so I'd love to know how much it's worth. Let's see, where did I park it? Oh, right there. That's what we're going to. So.
Pretty nice.
Oh yeah?
Got the Jaguar on the front.
It's also fuzzy. So what do you think?
So this thing's worth a lot, to be honest.
Well,
There's the car into a Jaguar. This one takes a bit of explaining, but I guess back
Has arrived.
in college,
I'm Allie, and
in college she got a rejection note F. She got on there, so she decided to take the note, and she photocopied it, blew it up into a rug. Let's see if we can get to the end here. There it is, full size.
compelling way.
So I already unfolded this once and then I had to get it back exactly as it was, except it didn't have to be exact. But I wanted it to be, so I wasted over an hour frustratingly trying to figure it out. It's like folding a map if you're a mouse. All the while I have words like deficient and unsatisfactory staring back at me, reminding me to question if I should even be making the video that is currently being filmed. I am
Again, almost 2,000. What is this? 88 massagers make a vibrating piano. Okay, I won't touch that one. But I've seen a few more of her videos, but she is just insane. Somewhere she's got, you've seen the, these days they have the giant Halloween skeletons, like 8 feet tall or more. Well, she took one of those and covered it in little mirror squares, like a mirror ball, a disco ball. Turned that entire skeleton, over 30,000 mirrors she put on the thing to turn it into a disco ball. What is this? Pours wine. I make a wine barrel costume that works. Oh my goodness. What if Island Boy was metal? I don't know what that means, but what do we got here? Permission to Dance by BTS would be the best country K-pop hit. I make a chia tux and wear it to a 5-star restaurant. Oh my God. You cannot come to this page and not find something just blows your mind. Her creativity is off the charts, and things you'd think there's no way in hell she's going to get this, but she makes it, and she gets it done. What? My boobs. I tracked down a mean commentator to give him my boobs. Okay, I gotta save that one for later. But wow, over almost 2,000 of these videos. A gold 24 karat gold life size skeleton go along with the mirror one, I guess. Ellie Spagnoli. I'm so glad Eric turned me on to this woman, but she is just out of her mind. You gotta check it out. If nothing else, you'll be inspired to think out the box, maybe even create your own, what is this, BTS butter, but vintage. I don't know what that means, but I'll check it out. What is this? 9,000 pop sockets to create a giant drivable fidget toy. Oh my God. This woman, what's her name? Ellie Spagnola is her name. Interesting. It's her dog Braxton. She always a lot of times she'll do sculpt. Here we go. I'll bring this dog skeleton back to life. Bring this up. Internet's being pokey tonight.
All I have to do is work backwards from there to add his body back, moving to his many muscles, and then the smooth skin surface, and then finish with... Excuse me, what are you doing?
It was satisfying.
Look, Braxton's mad at you. Stop that! That is my art! Hey, Best Pally, I'm Allie, and Home Depot is selling a dead dog. That's awful. So, in this video, I'm going to bring Skelly's dog back to life. We have his bones. All I have to do is work backwards from there to add his body back, moving to his many muscles, and then the smooth skin surface, and then finish with fuzzy fur. Oh, interesting. He happens to be a spitting image of Braxton here, except he will be over 200% bigger if I can pull this off. So, first, let's...
This woman is out of her mind. I tell you, gotta check out Allie Spagnola. You will, if not inspired, at least you'll be entertained. And again, with nearly 2,000 videos.
Any tiny little screw up will be the difference between completely terrible and coherent poop joke. Hey, Best Pally, I'm Allie, and I
typical
have a
of my
6-foot
life.
rug frame that I constructed to make only one rug and haven't used since. So let's make something huge and outrageous.
All right, I gotta watch this one too. Pause that, save that till later. But go out and check out Ellie Spagnola. She is just amazing, incredible, off the wall. There's a car covered in chia. What's this woman gonna do next? I gotta check it. You tune in, check out what's happening next with her. Go check out her channel. You will be blown away. I promise you. It's just crazy nuts. This one is a top-notch creator by any standards. You got to check out Allie Spagnola. You'll be happy you did, and that's all I can say. So now back to the video. We'll send you on your way, and yeah, there we go. Wow, gang. Filming this video has been a bear. To give you a frame of reference, I started filming on Halloween, and Thanksgiving's just come and gone, so it's been a beast. But well, there's a lot of code. It's a long program, but this is easily my longest video to date. So if you made it this far, give yourself a pat on the back and a cold brewski if that makes you happy. Whew, but thank you so much for watching. Hope you enjoyed, learned something new, and gotta check out Allie Spagnola. You will definitely have a good time over there. Some great stuff there. Thanks again for watching the vids. If you have any questions, drop them down in the thing there. And till next time, gang, take care. And as always, hasta la pizza, baby.